அனைவருக்கும் வணக்கம். So today's topic is about the electric bill. First we will see the circuit arrangement of this electric bill. Here we have battery. This is positive, this is negative. Here we have a switch. These are all wires. So one end of the wire goes to a screw which is attached firmly. The positive end goes through a switch. These are all wires, and we have a copper wire, enameled copper wire, maybe higher, very high, number of turns is very high, and then this end goes like this and comes over here. So this is a soft iron core. Just to increase the magnetic flux density, we have soft iron core. Now if you carefully watch, the positive goes like this. So if you look here, it is going like this anti-clockwise. So that means it is north pole. We already know the notation for say north pole. So if the current flows, when you see from that side view, if the current flows through the wire is in anti-clockwise, then it is north pole. Similarly, when it comes, this current comes here, this is also soft iron core, this rectangular slab, and then if you see, the current goes here, and from this point it goes anti-clockwise. That means this end is north pole, naturally this has to be south pole. Or if you look from this side, it will be the opposite. So south pole, you know. So if the flow of current through the wire is clockwise direction, when you view from sideways, then it is going to be south pole. So the idea is this combined thing is acting as a magnet. Here it is electromagnet because current flows through the wire. If there is no current, it won't work. It loses its magnetic properties. So that's why it is called electromagnet. Only when there is current, it acts as a magnet. Now we have north pole, south pole. Just compare with the regular magnet. There also you will be having north pole and south pole. Okay. Now what happens is, this will act as an electromagnet. So this combination will act as a electromagnet. So when there is a current, it acts as a magnet. No current, it does not have magnetic properties. Okay. So first what will happen is, you are closing the switch. So current starts flowing here through the wire. So this will work as an electromagnet. Now what happens is, this lever, that is hammer, because of electromagnet, this is pulled inwards. When it pulled, attraction. So when it pulled inwards, this hammer will blow the gong or bell. So it makes sound. So when it pulls this way, the contact here is open. This is the important point. There will be sound. Meantime, what will happen is, there will be a open circuit because it will come here. So there is an open circuit. Now what will happen? There is no flow of current because here you see a open circuit. Because the current flows like this, it goes like this, and from here to here there is no connection. It's an open circuit, so no current will flow. So what happens is, this electromagnet is no more an electromagnet. So what will happen? This hammer will once again go back to its, because it loses this attraction property. So it goes back once again to the original point. That is, it will be like once again it will be in contact with this. Now what will happen? The current starts flowing, so it's now closed, it gets in contact with this screw, so the circuit is closed, so current flows through this coil. Now this once again will act as an electromagnet, so once again there will be force of attraction. So once again what will happen, this lever will come this side, okay, so making the circuit open. So once again it loses its properties, magnetic properties. So whenever this lever comes with the attractive force towards the magnet, the hammer will blow the gong. Therefore sound is produced. So this is the basic idea of the working principle of the electric bell. So it uses the electromagnetic principle, and based on a simple concept of when the circuit is closed, current will flow, when the circuit is open, no current will flow. So when the circuit is closed, these 2 points are getting in contact, so a force of attraction is there. Because it's an electromagnet, this is a iron material, so it goes and gets attracted towards the magnet. So what happens, that time this hammer will blow and a sound is produced, so circuit is open. When the circuit is open, the magnet loses its properties. Once again it will go to the original position, which is the contact with the screw. This is permanent, fixed. And once again, so this operation repeatedly acts and it produces a sound. So when the switch is open here, no current will flow, and this will not be an electromagnet. And I already told you the direction, not how to determine the north pole and south pole in an electromagnet. So these are the fundamental basic things that you have to remember about the working principle of the electric bell. Hope you have understood this topic on electric bell. Thanks for watching this video. Nandri.